solve the equation x squared minus x squared minus 4 over x minus 2 is equal to 4. And they tell us that x won't or cannot be 2, because if it was 2, then this would be undefined. You'd be dividing by 0. So let's see what x is. Let's see the x that actually satisfies this equation. So you might be tempted to try to express this with the common denominator of x minus 2 and then add these two expressions. But the thing that jumps out at me initially is that we have x squared minus 4 on the numerator, which is a difference of squares. Or if you factor it out, it's x plus 2 times x minus 2. So we should be able to factor this x minus 2 out. So let's do that. So if we were to rewrite it,
I'm going to pause here for a quick moment. Although this is Kahn's hardest rational expression, it's not really a true rational expression problem because x squared minus 4 does in fact factor with x minus 2. If we were really doing a rational expression problem, you would multiply everything by a common denominator. Of course, here being x minus 2. X squared times x minus 2 is x cubed minus 2x squared because we have to distribute, minus x squared minus 4 over 1 because x minus 2 cancels out with that x minus 2 on the right. And we have to distribute the 4 throughout the x minus 2 on the right-hand side of the equation to get 4x minus 8. The 4 distributes to both the x and the negative 2. Likewise, this negative sign in front of the second fraction distributes to both the x squared and the negative 4. So we'll do that right now. The reason why I'm interrupting Kahn is because he actually gave an example that is not exactly a rational expression, mainly for the reason that x squared minus 4 over x minus 2 does cancel out. Okay, we now have a cubic here, and we have to get everything on the left-hand side because that's how we solve a polynomial equation. We have to set the whole thing equal to 0. So I'll subtract the 4x over and get negative 4x. Likewise, I'm going to add the 8 on both sides. 4 plus 8 is positive 12. And this whole thing is equal to 0. Now I have a cubic equation here. I can solve this by using the rational roots theorem, but this actually has another way that we can solve it, which is slightly more difficult. So big sad face to this because this is not an easy way to factor. That isn't to say, of course, that it's not factorable. It is. We can group the first two terms and the last two terms. And then we're going to factor out the GCD from each of those groups. The GCD of x cubed minus 3x squared is x squared. And what's left is x cubed divided by x squared is x, and negative 3x squared divided by x squared is just negative 3. From the second group, I'm going to factor out a negative 4. And I'm left with x minus 3, because 12 divided by negative 4 is negative 3. And this is equal to 0. Now I have a common factor to both of these terms. It's x minus 3. So I can factor out an x minus 3. And if I factor x minus 3 out of x squared times x minus 3, I'm left with just x squared. Likewise, on the right-hand side, I'm left with just a negative 4. X squared minus 4, that's a difference of squares. So now I can factor this as x minus 3 times x plus 2 times x minus 2. And this whole thing is equal to 0. Now the only way that three things being multiplied can possibly equal 0 is if one of those or all of those things is equal to 0. So either x minus 3 is equal to 0, which means that x is equal to 3, or x is equal to 2, or x is equal to negative 2. However, look at the very top of this problem. We have an x minus 2 in the denominator. That restricts our domain. The domain here is x is all reals except for 2. X equals 2 is not in the domain, and therefore it is not a valid solution to this equation. Therefore, the only two possible solutions are 3 and negative 2.
Equivalent to x squared minus, instead of writing x squared minus 4, we know that's the difference of squares. That is x plus 2 times x minus 2. All of that over x minus 2. And that is equal to 4. And this whole time we're assuming that x won't be equal to 2. And because x does not equal to 2, x minus 2 divided by x minus 2 is going to be defined, and it will be 1. So those two will cancel out. And so we're left with x squared minus x plus 2 is equal to 4, we can distribute the negative sign, and I'll just arbitrarily switch colors here. We can distribute the negative sign. So we get x squared minus x minus 2 is equal to 4. And what we want to do is put this in the form ax squared plus bx plus c is equal to 0. That allows us to either factor it or apply the quadratic equation or complete the square, or any of the ways that we know how to solve quadratic. So let's do that. Let's get a 0 on the right-hand side. The best way to do that is to subtract 4 from both sides of this equation. Subtract 4. And we are left with x squared minus x. Negative 2 minus 4 is negative 6. And then 4 minus 4 is 0. That was the whole point. So we have x squared minus x minus 6 is equal to 0. Let me write it up here. X squared minus x minus 6 is equal to 0. And this looks factorable. Just have to think of two numbers, and when we multiply them, give us negative 6. So they're going to have different signs. When I add them, I'll get negative 1. So it looks like negative 3 and positive 2 work. So if we do x minus 3 times x plus 2. It's a little bit of trial and error, but 6 doesn't have that many factors to deal with. And 3 and 2 are 1 apart. They're of different signs. So that's how you can think of how we get to that conclusion. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. So that is equal to 0. So we have two possible ways to get 0. Either x minus 3 is equal to 0, or x plus 2 is equal to 0. Now, if we take x minus 3 is equal to 0, if we add 3 to both sides of that equation, we get x is equal to 3. Or if we subtract 2 from both sides of this equation, we get x is equal to negative 2. So both of these are solutions. And let's apply them into this equation to make sure that they work. Because these are solutions to essentially the situation where we got rid of the x minus 2. Maybe it had some type of side effect. So let's just make sure that both of these actually work in the original equation. So let's try x is equal to 3 first.